Good afternoon. I'm Dr. Phyllis West Johnson. I'm the Director of Journalism and Mass Communications. I'm welcoming the students and faculty here in attendance, especially those from JMC and also those in Meteorology and Climate Science. Today we acknowledge Earth Day's 50th anniversary. This panel is notably important during the time of COVID-19 and climate disruption. This lecture is funded by Phil and Dean Spuler Endowment. It's designed to help our students better understand the issues at hand and more effectively report and communicate these global threats to humanity. I see this session as extremely essential in creating and strengthening curricular pathways with our colleagues in meteorology and the climate sciences. This is our first step toward a defined partnership that is long overdue. First, some general housekeeping. JMC's Juan Serna is the producer of this event, and our academic advisor, Dona Nichols, will help with our Q&A session. Thank you to our audience, and we invite them to ask questions at the end of this forum. One final note, we're recording this session. I would like to thank our panelists for being here with us to discuss these timely issues. Now, a very warm welcome to today's moderator, Bob Sipchen, among whose many credits include Pulitzer-winning journalist for the Los Angeles Times, and he's also the former communications director of the Sierra Club. Thank you, Bob, for helping to organize and lead this discussion.
Thank you, Phyllis. Thank you, students, for caring about these issues that we're going to discuss today. I want to begin by saluting you for your bravery and resilience. It is unprecedented for you to be continuing your education under these circumstances. When Phyllis and Professor Nichols and I began talking about this several months ago, we were planning to do it in a format that some of you may remember. It was called Live and in Person. We were actually going to get together and have a panel discussion with a real audience. That's changed, as you can see. The upside of this, though, is if there is a silver lining, the pandemic has given us a really rare opportunity to look at some of the issues we're discussing today and to study and learn in real time from our collective global response to coronavirus, and to see what that might mean for us as we similarly grapple with the arguably more important, more significant problem, if more slow-moving problem of climate change. I was there 50 years ago for the first Earth Day. I was in high school. I can tell you that there was an incredible sense of exuberance and empowerment in the air. Our rivers were literally bursting into flames. The ocean was polluted. Our air was miserable. I'm here in Los Angeles, and I can vouch for the idea that for the fact that the air here is better than it's been in ages. We were exhilarated by this, and it was science that drove us to this conclusion that we had to do something about our environment. And believe it or not, and I say that collectively, we did. We made quite a bit of progress. Now, climate change is the issue. I know it's the issue that most young people put at the top of the list of the things they're anxious about. And I get that you have plenty to be anxious about today. So I also want to tell you, though, that you have an opportunity, I hope, to be in the vanguard of the next wave of environmental activism, to be in the next wave of reporting on these issues, doing science on these issues, or communicating on these issues from the perspective of various agencies or nonprofits. And with that, I'm really hoping that this discussion will give you some tools and also give you some inspiration moving forward. I'd like to introduce our very distinguished group of panelists. They are all on the faculty here at San Jose State University. Eugene C. Cordero is a professor of meteorology and climate scientist. He received his PhD from UC Davis and his master's and bachelor's from Cal State University Northridge. He has a special interest in ways to communicate and teach about climate change in ways that inspire action. and he's been instrumental in launching this university's Green Ninja program, which I hope he'll have a chance to talk to you a little bit about today if you haven't heard of it. Sen Chiao is professor of and chair of meteorology and climate science. He received his PhD from North Carolina State University, and his focus is on data analysis and numerical modeling of climate change and its effects on the environment. Climate modeling is something we've all heard of, and I'm hoping he will give us some insights into how it works and the challenges. Patrick Brown is assistant professor of meteorology and climate science. He holds a PhD in earth and ocean science from Duke University, a master's in meteorology and climate science from San Jose State, and a bachelor's in atmospheric and oceanic sciences from the University of Wisconsin-Madison. We're very lucky to have such distinguished professors here to talk about this. And I thought we'd get started by, I'll ask a general question. Novel coronavirus poses a global threat. Climate disruption arguably poses an even greater threat, and perhaps an interrelated threat. Looking at COVID-19 and climate change, I'd like our panelists to give us a little primer on the role science plays in identifying these threats and where it helps us in addressing them. You want to start with Patrick?
Sure, yeah. I mean, I would say, you know, science is like just so fundamental to identifying these threats in the first place, because when you think about it, like the coronavirus, a virus, is a totally invisible agent, and it presents this threat that we would have no idea exists if it wasn't for science and it wasn't for the careful trying to disentangle causality. You know, we used to perform bloodletting or, you know, sacrifice a goat when someone got hurt. And that was our way of trying to deal with it. And science has shown us better ways of doing that. And, you know, similarly, CO2 is a invisible agent. It's an odorless, tasteless gas. And that's something that we wouldn't even know exists. And so we wouldn't know that it presents any type of problem without the scientific revolution. So I think science is really just fundamental. It starts us off and allows us to understand causality.
Excellent. Eugene or Sen, do you have anything to add to that? Okay, I have a second question there that sort of piggybacks on that. How would our panelists say, is climate disruption changing our understanding of epidemiology? I know you're not epidemiologists, but epidemiologists aren't climate scientists. Is there a connection?
I'll start off here and say that you know, it is important for us to recognize what our science area is. But the notion that, and Patrick was mentioning this earlier, that we use this approach of science to try to understand nature. And as being climate scientists, the three of us have spent, you know, years and decades studying this issue quite carefully. I think what is novel here and interesting for us is to watch the speed of translation from identifying a threat or a challenge to starting to gather data, to starting to develop hypotheses and models for how this is, for what's causing this, and then what's going to happen in the future. And I found this to be very fascinating to see the speed at how this moves, and then how our society and people on the ground are dealing with this issue. So, you know, if Patrick or Sen was to write a paper about what's going on in the climate system or projections, those projections would be on the order for the next decade or maybe for the next few decades. And so people might react to that like, oh yeah, that's important, but you know, that's something that we're going to have to deal with later. But the speed at which we're seeing these are new insights. The coronavirus can be transmitted, you know, even before you're showing symptoms. You know, how long have we known that? And then how did we react to that? And then how does that change like how we're living? And so when we think about what that means in terms of climate change, we can apply the same principles. It's just that the time scales are so different that it makes this quite an interesting, as a scientist, to watch our society react. And I think it provides some parallels for our understanding of how we can communicate science to a general population.
Excellent. I was having a little bit of trouble hearing you. You might turn up your mic a little bit.
Okay.
Sen, did you have something to add to that?
Yeah, I think just follow on what Eugene just said. I think this is actually sort of like wake up call for everybody. You know, as we see the clips in the beginning, and then we suddenly realize if we don't do anything in terms of regular activity, our climate, our air quality, our CO2 would change into different scenario. And the same thing here, it's like you know, how as we human being, how we treat Earth, the Mother Nature. That's actually give us everybody a lesson to think about science, to think about climate change, to think about what we should do next.
Yeah, and I think that the government's response to coronavirus, you know, a lot of people complain that it's been too, you know, reactive rather than proactive, but I think that it's pretty impressive actually. Like when you look at San Jose State, we canceled class on March 9th. At that time, there were 0 deaths of coronavirus in California. And then the Santa Clara County goes full lockdown, shelter in place on March 17th when there were 12 confirmed deaths. And so that's all using, you know, knowledge from epidemiology and foresight from science to make very, you know, at the time, what seemed like very drastic measures. And I think that's pretty impressive, actually, that we were able to mobilize and do that in this proactive way. It's something that we haven't seen as much in climate science, probably because of the time scale. But I think it is a model where it's a mini experiment that shows that people can mobilize quickly in advance of a threat that hasn't materialized yet.
I might add to
Excellent
that.
point.
And can you hear me better now, Bob? Is this
Yes,
okay?
I can.
I think, yeah, that point that Patrick raises is really interesting because some epidemiologists have been saying that we should imagine that the reaction seems too strong. Like if we bend the curve appropriately, it looks like, oh, you know, we like in Santa Clara County right now, you know, hospitals have a lot of capacity for surge. And actually that's as a result of this lockdown. And, you know, but typically we're used to responding to disasters like hurricanes or an earthquake, where the disaster comes and then we react. And we're less used to this idea of trying to do something ahead of time so that we don't see the real impact. And this coronavirus is one of those examples, is if we had left it till we had 1,000 deaths in California, then we really would have this tidal wave. And yet because we were using the science and we were also using the examples of other countries that were a few weeks ahead of us, and using that data, we were able to bend this curve and reduce the potential impacts. And that's what we want to do with climate too, but the timescale provides, you know, a big challenge for that.
Yeah, and we also don't have, you know, it's kind of like with the epidemiological situation, like you said, we have these different countries, and so you can kind of see, you know, when they react at this point, where do they go, versus if they lock down 5 days earlier. You know, we see that within our country, that in California we locked down before New York, and New York, you know, just had order of magnitude larger problem, and so that's kind of, we can use that as evidence to say, okay, we're on the right track. We understand things pretty well. It's more difficult in climate science because we don't have a bunch of different Earths that are running the same experiment that we can say, okay, look at that one. That's what happened to that one. And that's what happened to that one. We just have one. And that's one of the big hurdles in climate science.
Good. I think we'll probably loop back to this discussion a little later again. Let's see if we can look at a little bit more of a positive side to this and see what lessons are there. We're seeing a reduction in CO2 emissions, as the video clip suggested, because of the impact it's having on us in staying in place, essentially. Are these likely to have any lasting effect on our international climate goals? And if you care to dip into what some of this audience's more focused interest might be, do you see how journalists could might be look at covering these positive effects right now? So the question, I guess, is what will we learn from the positive impacts we're seeing here?
I'll
start,
start,
Patrick. Eugene.
Yeah, so I had like 5 TV interviews yesterday about this subject, and you know, the news media wants to report on some good news, like so air quality is improved, and you know, the picture behind Patrick is of our South Bay area on a very clear day, and we have a lot more of those, and we have data from the roof of Duncan Hall, which Sen helped organize, showing black carbon aerosols. It's almost like a 75% reduction in this one aerosol for a 3-week period. That is pretty remarkable. And they talk about, you know, some kind of fish in the Venice, and you know, there's this notion that, which I think is true, is that the environment has improved. But then when they say, what does this mean long term? I think we'd all agree that if we return to business as usual, the pollution levels are going to return to business as usual, and the small reduction in carbon that we are witnessing today is only a small fraction of what we really need to get to make significant reductions to impact our climate. So for me, I think that the opportunity really here is actually a change of our mental state more than a direct physical change in our climate system. And that is that they say that every time you have a big transition in your life, you're more open to some type of behavior change. So if you move to a new school, go to a new university, if you get a different job or you move your house, then some of your habits you're much more likely to be able to be open to changing your habits. And I think business as usual is never going to return exactly how it was before this year started. And so I think that places us in an opportunity to maybe look at the world a little bit differently.
Okay, other panelists?
Yeah, I think it's important to separate, you know, the kind of short-term air quality, air pollution emissions from the well-mixed greenhouse gases, CO2 and methane and nitrous oxide, because we're seeing this drastic reduction in the pollution that causes air quality problems, and that's great, and that's one thing to kind of bracket, but the reduction in CO2 is basically meaningless in terms of long-term policy. So like, we saw like a downtick in the Great Recession, and we didn't see, that was a downtick in emissions, but we don't see that at all in greenhouse gas concentrations, because greenhouse gas concentrations are this integration of all the emissions over the previous century. And so that doesn't even show up. And so I wouldn't expect to even see this in CO2 concentration changes in a few years. Like you wouldn't even be able to pick it out. So it doesn't really do anything for climate goals, but it could be used to show the co-benefits of moving away from fossil fuels. That when you move away from fossil fuels, you also reduce these air quality degrading emissions, and so that's one of the co-benefits that can really be highlighted as something that helps not just with climate, but with more here and now health impacts.
Right. To be clear though, if we hypothetically and miraculously were to decide, wow, we really like this clean air and this lack of traffic, so we're going to stop driving our Hummers from now on, COVID virus aside, then the cumulative effects would begin to show some benefits, right?
Yeah, but it's still small. I mean, if you look at global energy consumption, it's still 80% from fossil fuels. And so if you look at how that's distributed, it's so well distributed amongst all sorts of different sectors, across electricity and manufacturing and transportation and just every activity that humans engage in that uses energy, has a carbon footprint associated with it. And so you need to change that base production of energy from things that emit greenhouse gases towards renewable energy in order to see any lasting change. It's not really going to be, you're not going to see it with some little component here or there, like no longer using, no longer driving Hummers, which another thing is like, you know, with oil prices crashing, like that doesn't help in terms of the relative, you know, costs of electric vehicles compared to internal combustion engine vehicles right now. But yeah, it requires system change at the level of the energy system to solve the climate problem. And so these kind of behavioral changes are on the margins, I would say.
Patrick, I've discovered, is a total realist. So I'm going to try to nudge him in the direction of hope a little bit here. Is there any hope you see? Do you think that this may be fundamentally changing, you know, our collective approach to energy consumption?
Well, I think there's a lot of opportunities in the, you know, potential stimulus bills that are passed. So in order to change our energy system from a fossil fuel burning energy system to a more renewable heavy energy system, we need a lot of infrastructure change. And it's kind of tailor-made for a situation where you have a bunch of unemployment and you want to employ people to build things. So we have, you know, we need high voltage transmission, we need electric vehicle charging, we need all sorts of updates to our electricity grid and to build more wind and solar panels throughout the country. And this seems like this is a real opportunity where it's like we have a pool of labor that wants to be employed, and we have projects that would be a major investment in the future of the country and of the world that are available. And so connect the two and go from there.
Yeah, I was ultimately mocked because I was so obsessed at the Sierra Club with images of people strapping on tool belts and climbing windmills. I wanted to show that the labor force could be redirected. And I think that's what you're talking about here. Sen, did you have anything to add to this?
Yeah, I was just thinking just along the line Patrick and Eugene just described. I think few things that this current situation that related to how we retrospectively thinking in terms of climate change, climate modeling, totally related. I think the few very important things is human factors. Oftentimes we forgot, we either overemphasize or underestimate the human factors in terms of how we do the projection, how we, give out information, and how we actually, on the other hand, the receiver side, how we actually digest the information as well.
Right, and I'm glad you brought that up. You have expertise in computer modeling. And one of the things we're seeing with this epidemic is social media is now swarming with self-proclaimed experts who are very critical of the computer modeling that's been done on the epidemic. And I'm just wondering if you're seeing any way, I mean, the same thing happened with climate disruption, where there are the deniers, for lack of a better term, who challenge the computer modeling because it can't precisely nail what is going to happen. I thought maybe you could talk about that a little bit for the journalists and communicators on the panel.
Yeah, I can. That's actually a good question. That's also I was thinking about that. As I mentioned, from the scientific point of view, from the climate change point of view, we really want to project what is the possible, I don't want to say worst scenario, but we kind of like we want to make sure this is the possible worst case that we would end up getting it. The reason behind is that we want to have people to really prepare for that. Of course, it end up like people don't trust it because again, computer model is computer model. You can get whatever the result you want from the computer model, and that's actually very dangerous things in terms of how we do that. A similar situation, the other day I was thinking about how this COVID-19 that related to simply just analyzing meteorological data, how we can do that. It turns out, quickly I realized it's really difficult to do it because, again, I say human factors. How we are unable to, we can control certain parameters, but not able to really control how human affected. For example, Patrick just mentioned about renewable energy. Eugene mentioned about CO2 drop during this time. But again, that's a short period of time. But if you think about long term, how we should do that? Essentially, the thing I actually don't have a clear answer on that. Maybe Eugene and Patrick can add on that.
Eugene?
I would just say that models are, it's not fair to criticize models because everything is a model. So every claim that you make about the future or about causality or anything, if I say, I think Biden's going to win the election, I'm telling you that I've simulated the election in my head, and that's the output of the model that's in my head. And so we have models of various complexity in epidemiology and in climate science. In climate science, they run the gamut from a single equation can be a mathematical climate model all the way up to millions of lines of code. And all they are is they're just mathematical representations of how we think the real, physical world is. And they are by definition simplifications, so they can't be 100% right by definition. If they were not simplifications, they would just be reality. They wouldn't be a model. And so we just have to understand that it's basically like, this is our best understanding of the climate system. These are the most essential equations that go into it. And when we increase CO2, this is how much warming those equations tell us, we should get. Or if the spread rate of the virus is like this, and we, assume some death rate like this, then we expect this many deaths, within some time frame, and that could be like a worst case scenario. And that's what was done with these epidemiological models as well. But I think it's important to communicate that, like, a lot of times what Sen was talking about is like, you want to put the worst case scenario on the table. That's very valuable information. It's not a prediction of what's going to happen. It's just saying, okay, what if we were to do nothing with the virus? What if everyone goes along and behaves exactly as they would normally? How many people would die? And that's very valuable to know that, and then to try to move away from that. And that's similar to what goes on in climate science, but I think it should be articulated a lot of times in climate science that we are putting out, like, what is the worst case scenario where, what if we were to just continue to burn fossil fuels as rapidly as we could? What if we were to go look for all of the coal that we could possibly find on Earth and burn it? What would happen to the climate under that scenario? And it's not a prediction. It's just putting that as a upper bound, and then we can move from there and make intelligent decisions from there.
Good. One of the books I teach in my class at Occidental is George Marshall's Don't Even Think About It. The subtitle sort of explains it, why we're hardwired not to think about climate change. And the argument there is that we really, as journalists and communicators, we really have an obstacle, which is that many humans are not like you, Patrick, or you, Sen, and able to easily grasp what you've just said, that projections are imperfect, and that you have to look at the worst case scenario as well as the best case scenario, and that it's going to fall somewhere in between. So I'm just wondering, I recognize you're not psychologists, but do any of our panelists have any suggestions about ways to break through that? What I agree is a basic human reluctance. And I think you're seeing it a lot with the pandemic now, where, people are sort of poo-pooing the early projections. Any ideas on that?
I'll start by saying that people are not necessarily good at understanding and managing risk. So this is really a risk assessment issue. And so we do buy insurance, life insurance or homeowners insurance or rentals insurance to try to manage that risk.
Mute your mic. Sorry about that. Mute your mic, Luca.
Oh, is that me? My bad.
So, and that's something that other communicators in looking at climate change have definitely illustrated, that we buy homeowners insurance in the 1 in 100 chance that there's going to be some kind of event, and that even in the medical community, when we go to the doctor, they might start to talk to us about the risk that we're taking. So those things feel real to us, but somehow climate doesn't feel as real. So we're not, if Patrick was to tell us that we have a 1 in 5 chance of seeing sea level rise to the level that it's going to flood, in the next 50 years, 10% of the Bay Area, and then you're thinking about buying a house there, then you might start to pay attention when you're thinking about buying the house. But before that, it might not feel as real to you. And so I think we have the challenge with risk. And then because climate change is this often to the future and the direct impact, we don't see it as much sometimes. That makes it challenging.
Good. Patrick or Sen, anything to add there?
Yeah, I mean, what makes it doubly hard is just that a lot of times the costs are much more tangible and in the near term, and you could see them. So if we're gonna pass a carbon tax, which like economists agree is kind of the most efficient, best way to cap CO2 emissions globally, that's something that you can calculate on your own, checkbook and your own bank account and see that you are being financially harmed for this situation. And so it's not only that the impacts are kind of socialized and spread out, not only over space, but over time. It's that the costs are very acute, and that makes it, I think doubly challenging.
Right. Eugene, I'm sorry, Sen?
Yeah, I just feedback on Eugene just said that one important, I think Eugene also mentioned earlier, for example, you use hurricanes in example, or earthquake, that people actually feel it directly, immediately that's going to get some impact. But climate change is oftentimes we see the number, we see the picture. Until we see the sea level rising, especially in coastal California, then we're really aware of that. That's related to what Eugene just said in terms of risk management. In fact, this is actually related to COVID-19 as well. For example, California acting very early, in terms of shelter in place, and then you see other states, for example, New York, other states, they end up much later. So number actually, you immediately see the difference. But on the other hand, you see the Midwest, or even Puerto Rico or somewhere else, they may not immediately see that impact because California is right at the Pacific. A lot of people coming from Asia or something that we immediately get impact. So then we act quickly. That's exactly the same thing in terms of climate change, how we feel it.
Good. And just to nudge you out of your expertise a little bit again, you're seeing the anti-quarantine protests nationwide now. And I'm wondering if any of you have thoughts on how that, what that might portend for backlash once we do begin addressing climate change again seriously as a nation. We've pulled out of the Paris Accords. I'm assuming that someday we will return to the global table in these discussions, but do you see that this backlash against COVID-19 quarantines and self-distancing might have some, does that cause you any concern about how the American public will react to whatever mitigation steps we begin to take with climate again? And Patrick, I know you have I think maybe I'm wrong, but I think the scenario that you teach in your class about a hurricane evacuation may have some relevance to this.
Yeah, so that's kind of just this idea of the, so we talk a lot about like self-fulfilling prophecies, like if you say that a stock is going to go up and that causes more people to buy the stock, and that's like a self-fulfilling prophecy, where this is an example of a self-defeating prophecy, where both in climate science and in the epidemiological projections, you project something bad that's going to happen, and then you react to that projection, and then that prevents the bad thing from happening. And so then it makes it appear as though that was unnecessary. It was unnecessary to take those actions because, look, I don't know anyone that's dying from the disease, or I don't see any climate problem. And I was in my class, I contrast that with the decision to evacuate a city when a hurricane is approaching, where when you tell a city to evacuate, that's a major cost, it's a major disruption to the economy, and people can leave. But if your projection was right about the hurricane, they can come back and see the wisdom of evacuating the city. And so that's what makes that, kind of this testable hypothesis that gives people more confidence in the science. With people protesting the lockdowns, I mean, it's an interesting question. There's just going to be people that disagree about the severity, the stringency of given policies, the duration. And it's not necessarily true that science dictates exactly what the policy should be in both climate science and in epidemiology. An epidemiologist can tell you under X conditions, we expect this many people in the hospital. And a climate scientist can say under this amount of emissions of greenhouse gases, we expect this in temperatures, and we expect this in extreme flooding. But the policy decision is weighing costs and benefits across a whole range of things other than that, right? And so, politicians actually, I think, kind of are the more qualified party to make the policy choices, because they're listening to constituents on all sides and being able to, they're trying to weigh all of the costs and benefits. And the scientists are kind of just articulating like information of this happens if you do this.
Right. Excellent. But do you have any, do any of our panelists have any suggestions about how to get politicians to, politicians are just as susceptible to some of the human psychological frailties that we all are. The Dunning-Kruger effect, which makes some people blind to the fact that they don't really have as much expertise as Patrick does in meteorology, only though they've only studied English literature like I did. Or, and there's then the confirmation bias where people are prone to look at only the evidence that supports their existing worldview. Do any of you have any thoughts about how to get politicians, and we don't need to name names, but to get politicians to actually look at the real science? I'm with you in believing that there's no such thing as set science. Science is like journalism is about challenging suppositions, but there is a consensus. And if our politicians ignore that, I think we're in trouble. Sen, do you have a response to that?
No, it's actually a very good question. And I keep thinking about that. For example, hurricane evacuation is one example. Tornadoes is another one. There's a real case. It just makes me think in quite a few examples. Right now, for example, hurricanes. I think in past few years, I forgot which case, but it was like afterwards I feel like why the government didn't say make the order evacuate. But end up I realized one thing, because it's actually take a huge efforts for the government, the decision maker saying, all right, you need to evacuate right now, because that costs a lot of money, a lot of resistance, a lot of things going on with that. That happened in hurricane, for example, that's the case. Happened in tornadoes, that's the case. Until people already suffer under that kind of scenario, that would learn a lesson. I think that's actually why. But again, back to current situation, people protect, against this idea of a quarantine. Actually, today I think that was the news. Those people went on to protect this quarantine. End up they got the group together, and then got more cases happen that way. So I don't know. I don't have a good answer on that, but that factor is still there. Yeah. Dunning-Kruger effects always there.
Yeah.
I'll share something.
Yes, Eugene.
This, Patrick mentioned earlier about models and how every projection we make is based on some kind of mental model or computer model. And in the new science standards that are being implemented around the country, modeling is one of the goals of what it is to learn science. And so when we look at, for example, I know we're not supposed to name names, but when we look at our president, he hasn't shown a lot of appreciation for using science and data. And he's not the only one. So we have a segment of our population that may not trust science and data or may feel uncomfortable about using that. And that's a real challenge. I think that's a reflection on our education system. And we are trying, and here's what we're trying to do at San Jose State, and I know you guys do this in journalism, is trying to create critical thinkers, trying to create people who can think on their own, make good decisions for their own benefits or for the benefits of our community. And so I think there's a real role for journalism in helping to educate our public about the value of science. And we've suffered from this in the climate science field, in that when we first, 20 years ago, when we first started talking about climate change, we only told other scientists, and we told them within peer-reviewed publications and in the conferences that we attended. And then we let that just disseminate. But what happened is that some of that information got hijacked by other sources who wanted to change the narrative and change in some way the language of what the scientists are trying to communicate. So it is really, when I hear some policymakers talking about science issues and diminishing some science or just disregarding it completely, I think that partly reflects a lack of understanding of the value of science. There's not just, as you said, there's not just one thing, but that approach to thinking and looking at credibility of the evidence and being able to make good informed decisions is what we want for our population, so that together we can make the informed decisions. And Patrick's right that policymakers hold that kind of centrally. They're trying to manage lots of different contributing demands. And so hopefully those policymakers have some of that thinking too. And it was a welcome relief to hear Gavin Newsom, our governor, really talking about the value of science and data and testing, that we can't make better decisions until we have the data to be able to support those decisions.
Well, I'm really glad to hear you as a scientist talking about the role journalists can play in this, and I totally agree with you. But I can tell you that most of the students in this audience, I suspect, recognize that the challenge for journalists is under siege right now. I mean, their work is under siege, both by the shrinking news industry and the fact that legitimate news agencies are under great financial stress right now, but also by the fact of disinformation. And so as quickly as a journalist can listen to you or Patrick or Sen and write a story based on what you're telling them, their audience is under siege by people who are intentionally telling a different story for their own ends. So that's a real challenge. And I'm wondering if this is an opportunity for you to talk a little bit more about sort of starting sooner with your Green Ninja idea. I assume that this is sort of a green literacy program, right? To teach critical thinking at a younger age. Is that right?
Well, our Green Ninja project, which started here at San Jose State and now is in schools throughout California, the goal is really about science literacy and science thinking, and be able to use that to make good informed decisions. We use the context around the environment as a method for teaching science. And we want students to see the value of preserving their local environment. But we also want them to use scientific thinking for that, science and engineering. So that is related to what I was mentioning, is that I believe that if we can start that type of thinking early, that when they become voters and decision makers and decide decision makers for our public good, that they'll make those decisions based on scientific thinking and data and evidence, and that will benefit all of us, including our environment, but jobs and how we collaborate with other countries and a whole sort of things.
Good. Patrick or Sen, do you have anything to add there?
I think we just want to add on the, from the Meteorology and Climate Science Department perspective, and it's just try to echo Eugene just said that education is really essential component of this, and as the department is how we actually make our curriculum, make our classes that to following what's going on, to really make students engage on activities. That's actually very critical. So I keep, that's actually one of the things as a department I keep thinking in that way.
Excellent. And
yeah, I was just gonna say that I recognize the problem, in journalism that just because I spend a lot of time on Twitter and I see how something that's just pithy and that like either causes outrage or like can be seen as just punching your ideological opponent easily, like that is so click worthy and so retweet worthy and so easy for that to go viral. And like that's exactly kind of the opposite that we want to be doing in science. Like we want to be carefully thinking, we want to be weighing nuanced issues on all sorts of things. And so I don't have a solution, but I recognize how difficult this is, that if you want to write a 4,000 word piece that like investigates, on one hand, on the other hand, type of thing, which is what I'm kind of the most interested in terms of like learning about a subject, that's going to have a much smaller audience than just quick clickbaity kind of punchy piece. And I don't know how to deal with that, especially if it's all ad revenue driven.
well, that's obviously a discussion for 5 more panels. I am made hopeful though by panels like this, where it looks like the journalism and communications programs are beginning to integrate a little bit with the science programs, so that scientific learning can inform the reporting at a really basic level. I think that's really encouraging. I mean, I think journalism, in my journalism classes, I teach Carl Sagan's, I'm going to use an expletive here, so forgive me, but Carl Sagan has a bullshit detector that he encourages, that sort of reflects the scientific method. And I think that scientific method is essentially what good journalists, good skeptical journalists use too. I do, I'm encouraged by the young journalists that I work with and their ability to tell those stories you're talking about, Patrick, in a compelling way. It's not for lack of talent, it's not for lack of initiative by young journalists, but the platforms per se in this age of information and disinformation make it really, really challenging. Anyone have anything to add to that piece?
I will say that just for the journalists here, and there's a whole bunch of them, that I'm just very grateful for this profession, especially over the last few years, because once we make it an opinion about fact or not fact, that is going to undermine our ability to operate a good democracy and to do good science and make good informed decisions. So it's critically important, the role that journalism plays. And I know it's been especially challenging over the last number of years. And so I want to say, good job for these young students who are working in this space. It's not going to be easy, but it's super important.
Thanks. We're running out of time here. I wanted to ask a couple more questions, and then and as we're asking these questions, I think if we could begin shaping this towards helping the journalists and communications professionals in the audience think about how they're going to do their job moving forward. I think that would be useful, and then we're going to have questions in a second. But one of the questions that came from the panelists is that it's a hypothetical question. If in 3 years COVID-19 is long eliminated, but we're still suffering the consequences of a major economic downturn, will the public and politicians have more or less of an appetite for drastic action on climate change? And I'd add to that, you know, as we're looking at that problem, how do we report on it and how do we communicate about it? Patrick, did you want to weigh in on that?
Sure. I would say that in normal times, when you do, you know, polling of the public about what issues they think are the most important, like the economy is almost always at the top of the list, and climate change is definitely further down on the list, if not at the bottom of the list of issues that are polled, and that's in normal times. And so if we are in, you know, a Great Depression type of situation, that's only going to be exemplified more. So I would say that you can't frame it as though this is a, you know, sacrifice economically for the future. You have to talk about the benefits, you know, the air quality benefits of moving away from fossil fuels, the jobs benefits to the extent that there's a large portion of people unemployed. Just framing it in terms of, you know, a positive vision for what's going to happen here and now, rather than, you know, we're doomed, but we're less doomed if you make further sacrifices right now.
Excellent. Sen or Eugene? Okay. So I've had a career that I began as a journalist and became a communications professional, and then returned to journalism. And that's something a lot of professionals do these days. And I want to, Patrick reminded me that, you know, he said you want to do these stories that are on the one hand, on the other hand. And Patrick and I have talked about this. Neither of us are, when we're saying that, we're not saying on the one hand, the climate may be warming up. On the other hand, it may not be warming up. That's not what we're talking about here. But so journalists have stopped asking, or have stopped framing the discussion in those ways. But I do think there's a distinction to be made here. As journalists, your job is to be honest and accurate and fair and balanced. And that means you're going to still continue to ask these scientists questions where the answers are going to be nuanced and complex. And you have to decide how to deal with that problem, that challenge. As communicators, if you're doing public relations, your job is to message. Well, I mean, conceivably, some of you will be working for Exxon, so I'm not going to help you with that messaging. But some of you will be working, as I did, for environmental nonprofits and organizations that are working to solve the climate crisis. And you're going to have to figure out the best ways to tell people in ways that motivate them. And between those two challenges, I think these scientists are the crux of what you have to work with. So I'm really grateful to them for having been able to take a little time here to explain it. And I'd like to give them like one more opportunity. Anything you'd say to the journalists and public relations professionals, the students who are thinking of going into those fields, about what's working and not working in terms of their reporting and their messaging? I know whenever I speak to scientists, they express frustration with my tribe, the journalist tribe, or with my other tribe, the communications tribe. I'm wondering what this group of panelists might have to say. How could we do our jobs better? Patrick, you're on screen for me. You want to start it?
Okay, yeah. I guess just picking up on your on one hand, on the other hand thing, I think it's really worth it for a journalist to figure out where the line is between, you know, something that's very well established and something that is, you know, more speculative. So if you were reporting on the virus, you wouldn't say, on one hand, some people believe that viruses cause illness, and on the other hand, other people don't believe in viruses. Or, you know, you would go towards, okay, we know everything, we know about this virus, but on the one hand, some people think that we should follow the policy just like they did in Wuhan, China. And on the other hand, some people, you know, think that we should follow a less stringent policy. Like, that's what I'm talking about. And same with climate science. Like, there's no debate about that it's getting warmer and that greenhouse gases warm the planet. But, you know, where on one hand, on the other hand might come in would be, you know, they're planning more coal burning power plants in India, which would ostensibly bring a lot of people out of energy poverty. So there's costs and benefits directly, you know, with those associated with those power plants. And so then that should be reported honestly and openly. So I guess that would be my advice, is just delineating between, and it takes a lot of work if you don't know ahead of time, but delineating between what's established and then what is more open for debate.
Good. Patrick or Sen?
I just want to say that for the future journalists or communicators, one thing very important is that, again, from the department perspective, I would encourage you to come to the department and take some certain courses that to build up your, not necessarily domain expertise, but at least you learn something from the class, learn something from the reality that when you do your report, that will help a lot. So that's actually, I would suggest.
Eugene?
I'll share, piggybacking on what Sen said, I'll share a story that we discovered at the American Meteorological Society, which is the professional society in the United States for meteorologists and climate scientists. And what we discovered was that many broadcast meteorologists who are on television turned out to be kind of skeptical about climate change. This is over the last couple decades. And one reason they were skeptical is that they were very used to these weather patterns that change, and we can't predict the weather 7 days in advance. So they kind of put into their head, well, how could we predict the climate, 10 or 20 years in advance? Not all of them, of course, but a larger percentage than we would think from scientists, from the scientific community. So a number of organizations started to try to educate broadcast meteorologists who are also important science communicators. They're on television every day, and there's people who really trust and connect with who's giving you the forecast. And they've shown some really, and they applied science to this too. And they've shown some really strong improvements in educating broadcast meteorologists about some of the nuance of being of climate science. That, okay, not every storm is related to climate change, but on average, we're seeing more intense, for example, more intense rainfall in the Northeast. Or, so there are some real tangible pieces of evidence. And so over a number of years, these types of programs have actually improved the reporting about weather and climate to television viewers. So it goes back to what Sen was saying, and I think that is part of the responsibility of journalists, is that maybe there's a couple fields that you're going to need to go a little bit more deeply. But also don't forget that you don't have to know everything about every topic, but what would be great for you to embrace is scientific thinking, is cause and effect, is how to use models, is thinking about patterns. Those are the fundamental ideas behind good science thinkers. And if you can start to feel more comfortable with that thinking, you can apply it to all these different kind of science topics that you may encounter.
Good, and thank you. And you remind me that lest any of the students in the audience are thinking, oh, my job's gonna be really easy. I'm kidding, it's not gonna be. Let me throw one more monkey wrench into it. I mean, Patrick and I were talking earlier when I was the environmental editor at the Los Angeles Times for a spell a couple of years ago. A professor at UC Santa Barbara, my alma mater, was on a campaign to criticize journalists for not mentioning, whenever there was a wildfire or hurricane, this professor was scolding journalists for not linking it directly to climate disruption. And this is the problem you're going to have in both communications and in journalism, is that if we want to solve the climate crisis, which we all do, we want people to respond to it. And one way to get people to respond to it is to tie it very clearly and distinctly to concrete events. On the other hand, as a journalist, your job is to do what these panelists have been saying all along, and only tell the truth and only be accurate. And sometimes that gets you into the realm of nuance and complexity. And I am sure you will all rise to the occasion, but don't think it's going to be interesting. Patrick, did you have anything to add to that, since you're the one who brought me to that frustrating realization?
Yeah. So I don't have a solution to offer either. It's just that with a lot of these, I just recognized that it seems like there's been a trend towards connecting kind of every piece of bad weather to climate change, because I think that it's been recognized that that's been effective messaging, at least for some portion of the population. And that's getting into kind of tenuous grounds scientifically. It's moving away from the more established areas of the science. And so I get uncomfortable with it scientifically. It's, you know, there's a lot to unpack there with each event and, you know, what specifically you're talking about, but it's definitely less straightforward than some of the more basic things like, you know, sea level rise or something. A sea level rise is just straightforward. As it's getting warmer, the ocean expands and ice melts and sea level rises, and the warmer it gets, the more likely we have to build seawalls, and that's a negative consequence of climate change. But when it gets to some of these specific types of events, it gets a lot more complicated. And so that's a trade-off that people are going to have to make when they're covering them.
Excellent. And maybe to turn the tables just a little bit here, my unsolicited advice to the panelists is something that you've all actually inspired me to say, which is that one way scientists can help with this is to value the power of storytelling. And you're all doing that. You're telling stories as opposed to just, you know, conveying data, which is how you have to communicate in your own realm. But as you're trying to connect with the public, the way you've been doing it today, I think is very helpful. You've been telling stories in a way that people can actually grasp the challenges and issues. If no one else has anything to say here, I think we can go to questions now. I believe that Professor Dona Nichols is going to help with getting some questions on the table.
Mauricio, you have a question?
Oh, yes, I do actually. I wanted to ask on the panel, how do you prove to people that the Earth is a globe? And it's actually a serious question, so.
Well, I'll offer one, but Patrick, I'm sure, has some too, and Sen. I think that anytime you're trying to answer a question like that, a scientific question, that you would be looking for some type of evidence. And you might form a hypothesis, you might start thinking, but one line of evidence is looking at the shadow of our planet during an eclipse. A lunar eclipse provides a shadow of the Earth backgrounded by the sun, and we see this curve, and we're seeing the shadow of our planet. And I think that was a way that early folks started to confirm their understanding. There are other lines of evidence. Was there any, Patrick, that convinced you that we were on a sphere?
Yeah, I'm trying to remember. I did dig into the flat earther stuff for a while, but it's you know, I would establish an experiment where I called someone in India and kind of synchronized our clocks and said, you know, when it's day for me, is it night for you? And what's the best, you know, way of thinking about how that would happen? Like, okay, a globe makes sense for that. We could talk to a friend in Australia and discuss how when it's warmer during the summer for us, it seems to be colder and it seems to be your winter at the same time, and discuss how the model of a globe and the tilt of the Earth makes perfect sense of that. And it would be difficult to make sense of that if you were in some type of a flat Earth situation. But yeah, it's all about kind of basic forming models, and forming from your models, then you come up with hypotheses to test. And so it's very similar to what would be going on in any type of sciences. How would you it's a good question. How would you, prove that the Earth is a globe? How would you prove that the Earth is warming from greenhouse gases? Similar type of thing.
Yeah, I suppose I ask it mainly because obviously us laymen journalists probably lack the scientific knowledge you guys do. So, in that sense, why is it important to also understand ignorance and what makes people ignorant? Does that make sense? Because obviously people think there's flat Earth, and
yeah, I would just emphasize, not so much bludgeoning people with authority and facts, and just emphasize that we're just trying to figure things out. We're just trying to use our minds, and that's the scientific method, is essentially just being careful with our thinking and forming hypotheses and trying to test them. And it's no mysterious, crazy thing that's behind curtains or closed doors. So just opening up the process, I think, to everyone would help people see that it's not something scary or something that's intended to come and take their freedom away or something.
Right. Thank you, Mauricio, and thank you also, Patrick. We have a few other questions. First, I'd like to go to Amani with his question.
Actually, it's Amani. So my first question is, in addition to being a student here at San Jose State, I'm also a contributing writer to, wait, hang on, sorry. My mic is not working apparently.
Mauricio, okay. Mute your mic.
Oh, my apologies.
Thank you. So sorry, in addition to being a journalism student here at San Jose State, I'm also a contributing writer at Metro Silicon Valley and San Jose Inside. And I'd actually already emailed Professor Cordero when I heard that this summit was happening and thought I'd join in. So my first question is to Patrick and Sen. Would you be willing to submit to an interview for a piece that I'm writing for Metro Silicon Valley?
Sure.
Sure.
Excellent. I will be emailing you. It probably will not come from my SJSU email, but I'm a Manny. Hello. My second question is, obviously everyone is a bit stunned by the amazing air quality that we've had. You kind of touched on this earlier, where this is not a long-term solution to global warming, to climate change, even to our local air quality. This is going to go back to normal smog and haze and pollution when we go back to normal. So this will be, just a blip. Is there anything that we in the Bay Area can do beyond business as usual to permanently change our air quality for the better?
You could, nice to meet you, Amani. Thanks for your email. I think that the folks our colleagues in urban planning here at San Jose State have a master's program, spend a lot of time thinking about that question. I will say that our air quality in California is better than it used to be. Bob mentioned that, or it's to start off with. So we've made definite improvements. We still have a ways to go, but California has developed around the automobile. And most of 99% of today's automobiles, burn fossil fuels and have particles and gases that come out of the tailpipe. So it's a real big challenge. And in fact, if you look at the carbon emissions for California, depending on the metrics that you use, the biggest piece is by far transportation. We've been able to clean our electricity grid much more easily, much more cost effectively, but to change transportation is a really big challenge. And that's the primary polluter for the air quality that you mentioned. So the problem's going to return, but there's a large incentive, and there's lots of people who want to improve the air quality. And not just that, they want to reduce traffic, because nobody enjoys a 1-hour commute to San Jose State sitting on 880 or 680 just stuck there. And so that could improve quality of life. So it's really a fairly broad issue. And it is not something, it is, when you talk about Silicon Valley or the Bay Area's biggest problems, we talk about issues related to housing and traffic. And traffic and pollution are interrelated. So I I'm not going to be surprised to see the pollution levels return, but I am looking forward to more innovations in this area around trying to improve one of our biggest challenges, which is transportation.
Senator Patrick, do you have anything to add to that?
Yeah, I want to mention that, as you may know, California is really ahead of the game in terms of, for example, air quality. I would say that actually, from my own experience, a few years ago, I did a project for California Air Resource Board. They try to measure the incoming ozone from Pacific into California. So there's several different perspectives in looking into that kind of project. For me, I'm trying to measure in terms of scientifically, but for them, actually, I realized they want to make the policies because the EPA lower the standard to 75, actually bring higher standard, 75 parts per billion in terms of ozone. So if anything's, let's say factory or whatever, greater than 75 parts per billion, they would give the ticket, they would fine. So that's actually the way they end up trying to do control ozone, for example. That's one thing. Again, right now they shift the ozone from to PM 2.5. I believe they are doing something like right, making some policy, making something. And then again, California people have actually more that kind of mindset to accept it is kind of changing. That's what I think.
Thank you so much. So one of the things that I'm hearing from Professor Cordero is that this is really a huge opportunity for us to address some big problems that have been plaguing the Bay Area for a long time. And in my head, I'm just envisioning like a high-speed light rail sort of a situation that would really help us, reduce traffic congestion, clear the air, have available transportation, link up more cities potentially in a way that doesn't have you hopping from Caltrain to BART to Muni. Would that be a viable solution to taking cars off the road, and how would we incentivize that politically in any way?
This is, I have a little bit of experience in the transportation sector, and I know how challenging it is. You try to take away a parking spot on San Salvador, and you have to go through public review. You got to put that out. You got to talk to the business owners, and you have to give 3 months notice. And when we start to tweak our infrastructure, even in small ways, you see the real challenges of multiple different communities weighing in. In some way, it would be nice to, and you can imagine being China for a while, where you have a totalitarian regime where they just do things and they install high-speed rail all over and then it's done. But there were a lot of negative, even environmental aspects related to that. So, we are going to experience a big change. So I agree with you. This might be an opportunity for us to rethink how we do business and how we move around and how we support a more livable community that's more affordable, that produces better air quality, and that's more more enjoyable way. It's going to be a challenge, but this is a good opportunity for that because of this big shift that we're experiencing.
Thank you so much. Look out for my email. I will be emailing all of you very shortly. Thank you so much.
Okay, thank you both. And we have a question now from Zenny.
Hi, so my question is that I saw some articles online that there are airlines that still use fossil fuels because they don't want to lose their air, like their flying time. So is there a way that we can convince airlines to not fly during this pandemic? Because people are saying that the airplanes are not very full, so I don't see there being a reason for airlines to fly right now. That was my question.
Who on the panel feels like they'd like to answer that? Eugene?
Yeah, we'd have to look at the data to see what's really going on to make an informed recommendation or answer your question. But it must make financial sense for the airlines to continue to fly. There must be a reason for them to do it. Otherwise, they wouldn't do it. So I do believe there's fewer planes in the air. I've seen some statistics from San Francisco and San Jose Airport. But of the planes that are continuing, they're, when they only have 4 people on the plane, they're not making money on the tickets, but there may be some other reasons for them to do that, to keep their place or to, but not knowing really why they're making these decisions. There's going to be another side of the coin here that might explain the rationale, because they're not stupid people. They're doing this for a reason.
Oh, okay.
Anyone
Excellent.
else?
Thank you.
Zenny, can I ask you a question?
Sure.
How eager are you to get back on an airplane right now, knowing what you know about COVID-19?
I'm not very eager, but I heard from my friend that because she had to fly back home to Korea, that like pretty much everyone was in full mask, and she was wearing like a protective head covering and then mask and gloves, and I feel like that must be very uncomfortable for the few people who do have to fly.
Yeah, I think we're at an interesting moment where we're examining what's important to us and what our needs are versus what our wants are in fundamental ways. And I think in a sense that's encouraging.
We don't have any more questions from the students unless anybody wants to jump in right now. Daniel White has a question.
Yeah, just to kind of piggyback on Amani's question about, reducing traffic and trying to make the air quality better in the Bay Area by, light rail or whatever. I know Patrick said earlier that, to really curb anything, it needs to start at base production. But Eugene was saying, when we go back to business as usual, everything will go back. But I was wondering, a lot of people are realizing that they can work from home, maybe not go to the office as much. Do you think after the shelter in place is lifted, if more people weren't commuting and were working from home more often, then we would see a little increase in better air quality?
I think that's the best chance of anything coming out of this. I think that, the direct experiment of everyone working from home and seeing how well that goes. I really have no idea what's going to happen, if there's going to be a backlash and everyone says, this is why we don't work at home and going back to the office, or if it will really stick. But it seems like that's the most obvious, straightforward thing, is that like some certain fraction of people never go back to the office for 5 days a week, or never, go to a campus the same rate that they did before. And so as long as there's not a loss of quality of work and of education, that's a good thing as far as emissions are concerned.
We have a question from Valerie Brunt. She asked, instead of celebrating Earth Day just once a year, how can I make a difference in our environment?
It's Eugene.
Well, there's various ways. When I calculate the carbon footprint of an average San Jose State student, just like as a simple metric, there's three pieces to this pie. One piece is transportation, how you move around. So you might think about, reducing, maybe you take the light rail or a bus if possible, instead of driving your own car. That's a possibility. Another piece is about how you interact with energy at home. Can you be more energy efficient, to maybe shorter showers or hang your clothes out to dry, or those kind of things. And then the third piece is about food. And actually, in many cases, that's like the easiest thing, because we get to make food choices 3 times a day. And so here at San Jose State, I've become this character as well as a professor. I'm also known as Dr. Burrito, because in some San Jose State films, Screen Ninja films, I've been interrogating the carbon footprints of different flavors of burritos to try to see what the climate impact is when I go to La Victoria, which I hope many of you have been to La Victoria. I'm missing my La Vic orange sauce for breakfast burritos. But when I go and make a decision about, do I get a carne asada burrito or do I get a vegetarian or a chicken burrito? Turns out that the carbon footprint is really different. And so one thing that people can do is that they can reduce their consumption of red meat, or, so that isn't, you have that every day. Maybe you have it one day where you don't have it, or you choose the veggie burrito or whatever it is. And I think that's actually the easiest thing, an easiest way, and actually a very interesting way to make a change in your life is to start thinking about your food choices from a personal health standpoint, but also from an environmental. And it'll lead you into lots of different books and discussions. And I found it fascinating myself.
Okay, we have another question. We are always finding new things in science. How do you address the perspective that those wary about global warming are wary about extrapolating a conclusion from incomplete data, especially linking it to something anthropogenic?
Yeah, so climate science is actually like a very well vetted, mature science. So it was Joseph Fourier in 1824, I believe, that first proposed the existence of the greenhouse effect. And a lot of work was done in the 1800s. Can you still hear me?
Yes.
Okay. A lot of work was done in the 1800s to establish that different gases can trap heat in different ways. And so that even going up through the 20th century, in the 1970s, there were reports out about climate change. In 1975, there was a major paper that predicted the warming that we'd see over the next several decades. So I think there's a misperception that like scientists are just looking at this now and they're looking back at past data and coming up with explanations, when really it's much more powerful than that. It's this fundamental science, and there have been predictions made, and those predictions have come to pass. So I wouldn't say that it's incomplete data when it comes to those basics. And so I guess it would be important to communicate to someone that this is something that has been established for decades, if not over a century, and predictions have been made and they've come true. And so that really validates the science.
I believe that's all that we have, but I do have a question for our panelists that ties in the climate change science along with COVID-19. I believe that it will be the scientists we look to ultimately to get through this pandemic. Do you think that there's a way that you can garner more credibility for climate change by looking by validating the scientists we've looked to in the pandemic?
Well, I want to say something here that I have found that Andrew Fauci has been amazing because he has kept his science as front and center and kept his job at the same time. And that is a real skill. Like most of us would probably already like either quit or been fired. So it's really, I would imagine if you talk to him or he writes his book later on, that he really thought about how to make sure that his science continues to come out of the White House, because it was not a pro-science White House. But yet he maybe sometimes he has to back down a little bit on some things, but he's still there. He's still advising the president. He's still advising the national agenda. And that for me, like, I really think, gosh, this guy is doing, and there's a woman there too, those two folks there are doing a great job of keeping that science message there, even in a somewhat could be perceived as a hostile environment. And that I think is really effective for us as scientists, how we communicate science. Sometimes we got to change our approach, and maybe he had to do that to be successful.
I think it's important for science to be viewed as a neutral party, especially as a politically neutral party. So the Trump administration, of course, is accused of being anti-science, and Republicans in general are accused of being anti-science. But if you define science as just kind of logic and reason and careful thinking, nobody defines themselves as being anti-science. So what they're anti is they have a perception that science is essentially a wing of the progressive movement or a part of the Democratic Party. And so I think it's really important in order to maintain credibility to not fuse science with any political movement. And I think that there's issues with like the March for Science and things like that that are kind of moving in that direction. And so just keeping science neutral and not prescriptive necessarily politically, but more informative of policy, I think is important for credibility.
And I just want to add, at the end, data will support the science. Data will support the evidence. That's actually how we get the science.
Thank you.
Excellent points. And I would say that is, I'm of the school that would say journalists should be in a similar position of, I'm an old school objective journalism fan, which is not to say that advocacy journalism doesn't have its place, but I'm with Patrick on that. And, I think that our credibility is based on being fair, balanced, and accurate.
Awesome, guys. Fantastic.
Well, thanks, everyone. It's an honor to have been a part of this. Thank you.
You got a lot of thank yous. Got a lot of thank yous, team, from all the students saying that they learned a lot from this, and they're really happy that you guys were able to come and spend time with them. So thank you very much for spending time with us and teaching us all something new.
Thank you.
Thank you. Yeah, appreciate it.
Thank you.
Thanks, everyone.
Hey, panelists, if you don't mind, we're going to hold